Okay, we're going to look at the rest of this week at one of my favourite topics in maths, Pythagoras. I just find this absolutely fascinating that it's such an old topic, and it's all to do with right-angled triangles, and workmen still use Pythagoras Theorem whenever they're trying to decide if something's a right angle. I'll give you a bit of background about it just because I am such a nerd about this topic. Pythagoras Theorem starts, first of all, the side opposite the right angle is called the hypotenuse. Long word for long side. And what Pythagoras said, if you add the two sides at the right angle, so you add the two sides at the right angle squared, it equals the hypotenuse squared. Now, they don't normally write it out using all those words. So what they tend to do in Pythagoras, whenever they're describing it, they call the sides at the right angle A, B, and they call the hypotenuse C. So A to the right angle, A squared plus B squared equals C squared. Now I'm just going to show you this just for your own knowledge. You have some very special triangles. And this is a 3, 4, 5. And if I apply Pythagoras Theorem, so 3 squared add 4 squared, it equals 5 squared. So Pythagoras Theorem works very nicely for this triangle. And these three numbers together are called Pythagoras or Pythagorean triples. You'll never be asked that, but it's just nice to sort of know. If you have a 3, 4, 5 triangle, it's always got a right angle. Another Pythagorean triple is the 5, 12, 13. So if you check this out, 5 squared add 12 squared does give you 13 squared, because 25 add 144. If you add those together, it gives you 169, and 13 is 169. So it works. That leads me to this wee example. Is the triangle below right angled? So I have this wee triangle, and I'm going to say this is 5, this is 6, and this is 8. It looks right angled, so I'm going to check it out. To check it out, you take the two squares the two sides at where you think the right angle is. So 5 squared add 6 squared, does it equal 8 squared? So 25 add 36, my handwriting's bad there. So 50, get this right, 61 does not equal 64. So this is not a right angled triangle. So if they ever asked you if it's right angled, just try it out and see. Okay, now I don't really tend to bother with the ABC. The way I would do it, I'm going to show you two examples. So this is a right angle, this is 36, this is 15, and I'm looking to find x. I wouldn't write out a squared plus b squared equals c squared. What I would do is I would go to the right angle, and I talk about my finger and thumb. I open it up. See there? Right angle, finger, thumb, open up. So 15 squared add 36 squared equals x squared. So I would just go straight to the calculator. I'll just show you me putting this in. So 15 squared add 36 squared. Press the equals button. 1521 equals x squared. When you're bringing the square over, opposite of square is square root. So x is the square root of that answer to give me 39. And truth be told, I even would cut that down further when I'm doing an example. So once you get the hang of it, don't be afraid to even just do it as quick as what I'm going to show you now. So let's say this is 8 and this is 7, and I'm looking for x. I go to the right angle, and it's those two sides squared. And I'm going to square root it to get x. So quite often I do it all in one line. So on the calculator, square root, I'll try it again. So square root 8 squared, add 7 squared, press your equals button, and press SD to get it as a decimal. So straight off like that. Now, with Pythagoras Theorem, you can be asked to find the shorter side. So if you look in those examples, I've always been finding the longer side, the hypotenuse. So what happens if I have to find the shorter side? Okay, I'll show you two methods. You can, if you want, call this side x. So here's your finger and thumb. You add these two together, and it equals that one. So you can work through this 7.2 squared, giving you 51.84 plus x squared equals 144. There's one side, numbers the other. So that comes over to be a takeaway, giving you 92.16 and then square root. No problem at all if you want to do it that long way. I do it a bit quicker. So I would say, I'm looking for a shorter side. So I'm going to subtract the numbers. So I would go 12 squared minus 7.2 squared and then square root everything. So again, I've got my answer very, very quickly. It's up to you what way you want to work it. So what I want you to do now is I want you to practice out of your worksheet. So go and look at chapter 42 and we'll just work through some of the more basic ones today. So we'll do page 26. All of that should be okay. And I would say if we did page 105, it jumps. So page 105, question 3, and I'll post those answers later on.